Dear students, today we are going to start the study of our Unit 2 for SEPM subject, that is Software Requirements Engineering and Analysis. So it goes with the chapter 7 of Requirements Engineering from the book of Roger S. Pressman, that is Software Engineering, A Practitioner's Approach. So this we have already discussed earlier that any edition of Roger Pressman, Software Engineering book you all can refer, because maybe contents are located on different pages, but whatever contents and material is there, it is same in all the editions. Okay, so today we are going to start with this chapter 7 from Pressman, but it is actually unit 2 as far as SPPU syllabus is concerned for SEPM. So I again repeat the title of unit 2, that is Software Requirement Engineering and Analysis. So obviously this particular topic or section focuses on the requirement analysis, requirement gathering, then requirement elaboration, this particular concept from SDLC. So as we have many times come across this term and we have studied in detail in unit 1, that is what is SDLC, how it performs, different stages or phases in SDLC. So you all know that it starts from communication phase, then it goes to requirement collection, requirement gathering, analysis. After that it goes to planning, because once requirements are ready with us, we go into the step for planning of each and every minute detail. After that we jump into designing. In designing, or you can say modeling, where we are going to have some analysis and then drawing different diagrams. So these diagrams we are going to study in further presentations in the same unit, and few diagrams are continued in unit 3 also, design engineering, which I have already told you at the time of unit 1 study. Okay, so once these diagrams are ready, say in the form of flowchart or ER diagrams or UML diagrams, then once these diagrams are ready, our analysis and modeling is ready, then we are going to go for coding, that is implementation part, technical things, and then testing. Once this testing is also completed, then we jump into the last part of SDLC, last stage or phase of SDLC, that is deployment. So there we are going to launch or release the product and software, and we are just waiting for the customers or end users feedback. So these steps we have already seen. Now from these SDLC steps, now this particular unit 2 is only going to focus on requirement engineering and analysis. Okay, so as per the syllabus is concerned for unit 2, this unit 2 is divided into 3 parts or 3 sections. First section will talk about or will focus only on requirements engineering. What are the requirements, different requirements as per different case studies, how requirements are collected or gathered, okay, how the analysis is done. And once all these steps for requirements is done for any particular problem statement, the second section of unit 2 that focuses on requirement specification, which is also called as SRS. So in many books you will find SRS, that full form is Software Requirement Specification. Few cases you will find the full form given is Software Requirement Study, but the correct thing which you have to refer every time is Software Requirement Specification, that is SRS. So how to write down or chalk it down? Software requirements detailing, specification, elaboration, that will be explained in the second section of unit 2, that is SRS, Software Requirement Specification. Then going to the last and third section of unit 2, that talks about or that focuses on requirements elicitation and analysis. That means first section will talk about how to collect the requirement, that is requirement engineering. Second section, how to draft it in the template of SRS, Software Requirement Specification. And third thing is now going into the detailing, okay, to the core depth of those requirements, that is elicitation and analysis. So the third section is requirement elicitation and analysis. So in this way we are going to study all these 3 sections of unit 2. Okay, so first obviously, as the first section of unit 2 is requirement engineering, the same slide you can see on display. So requirement engineering, again you are going to remember all the words, all these terms which are given or highlighted in yellow color. These are the different steps or you can say different phases of requirement engineering. Okay, so let's start with the first one, that is inception. Okay, now inception will talk about, that means it is initiation or where you are triggering something. Okay, so it is establishing a basic understanding of the problem statement or the problem which is described by the customer or end user, and the nature of the solution, what kind of solution is expected or it is required from the end user. Okay, that you are going to describe or decide in this step. So I repeat, inception is something which you are going to initiate the system's production or manufacturing, okay, or something which you are going to give the trigger. So that something is establishing the understanding of what is the problem statement, what problem that a particular end user or customer is requiring, and what kind of solution he or she is demanding. Okay, so problem, understanding the problem statement and its solution. That is the first step, that is inception. Okay. The next step is elicitation. That means we are done with inception. Then I can say, just a minute. Yeah. So first is inception. Then we'll go for elicitation. Now what this elicitation is? Because just now we have seen the third section of unit 2 talks about requirement elicitation and analysis. Okay. So elicitation is drawing out the requirements from stakeholders. So first step means you are collecting the requirements from stakeholders, but now something you can say planning from those requirements which you have taken from stakeholders. Once again I repeat, stakeholders means number of users who are involved with that system. Maybe few people are involved in the planning of system, few people are involved in production, development or manufacturing of the system, few people are involved in testing or using or utilizing that system. Okay, or few people are involved in just managing the system. That means different users who are going to use that or interact with that system are stakeholders. So elicitation focuses on drawing out the requirements from stakeholders. So whatever requirements you have taken from all the stakeholders, not only from end user customer, which we are doing in first step, inception. Here in second step, elicitation means whoever is a stakeholder of that particular system, you are going to take requirements from those stakeholders and then you are going to chalk out some plan. Okay, so this elicitation is one step ahead of inception. Now third step is elaboration. As the word suggests, you are going to give some kind of detailing here, some kind of specification here, but obviously that specification will be about whatever requirements you have collected in earlier two steps. So elaboration means create an analysis model that represents information, functional and behavioral aspects of the requirements. So these three terms need to be clarified here. That is, what is the information given into that system or problem statement, what is the functional or functionalities or services offered by the system, and how that system is going to behave in different scenarios, that is behavioral. So these three terms are needed to be explained with respect to the system you want to develop or create or manufacture, and that is elaboration. So that detailing or specification is required here. Next is negotiation. As you already know this term, negotiation is somewhere you are going with some mutual agreement so that both or number of parties involved in that deal will have win-win situation at the end, because all are satisfied with whatever agreement mutually they are doing in between them. So negotiation means what? Agree on a deliverable system that is realistic for developers also and customers also. So you have to find out what kind of system will be feasible on both the sides. Both the sides means what? On developer sides for you can say construction and testing, on customer sides for utilization. So both parties should be happy and satisfied at the end. So some kind of mutual agreement or you can say paperwork or deal need to be signed in between both the parties. So both the parties must be agreeing on all the requirements and constraints. Okay, that is negotiation. Fine. Specification, just now I've explained all these things. Specification means what? That is detailing, some kind of explanation. So that's why the word is coming as describe the requirements formally or informally. Now this formally and informally means what? I think at the time of unit 1 we have studied the difference between black box testing and white box testing. That time I have told you in both the diagrams. The very first step is that these end users and customers are going to give some informal requirements to the developer, okay, or to the producer. Now what are these informal requirements? The term meaning is informal means something which is uncertain. Okay, the requirements which are not complete, which are not you can say correct, means they are just describing or visualizing or imagining the requirements and they are explaining it to the developer or producer. Fine. We are going to what you can say convert or transform these vague requirements or uncertain or incomplete requirements into the proper requirements. Okay, so specification is describing the requirements formally or informally. Fine. Validation, this we have already studied when we were into the introduction of testing phase in unit 1, where that review the requirement specification for errors, ambiguities, omissions and conflicts. So obviously validation means something you are going to monitor, check or assess. So you are going to assess your system for requirement specification. Are there any errors or some faults or gaps or some clashes or conflicts in the requirement specification? And last is requirement management, where you are going to manage the all what you can say changing or upcoming requirements. So now and then a number of requirements will be changing, or they'll be updating or modifying. So your system should be flexible enough to handle such kind of changes or modifications or updations in the requirements. Okay, so it should accommodate such kind of changes. So that is about the requirement engineering. So you can just count it. It is 1 2 3 4 5 6 7. So obviously the funda will be I E square N S V R. I repeat, I E square N S V R. So these are the features or principles for requirement engineering. Okay. Going ahead, each and every step you are going to study in detail. Inception, as I have told you, it is initiation or triggering some action with the system. So it will be focusing on asking some context-free questions. Okay, that means these questions will be some generalized questions. It is not with respect to some kind of subject or context. So what kind of generalized questions you will be asking to the end user or customer, so that you will understand a little bit about what their requirements or what their demands are. For example, who is behind the request for this work? What kind of party it is, or what kind of person he or she is, means what job they are doing. That means for what domain or scenario they need this product or system to be developed or manufactured or created. So understand who is behind the request for this work. Number two, who will use the solution, product or system, whatever you are going to provide, who are going to use that product or system or solution. Fine, that means you have to target the users. Okay, you have to visualize or you have to understand the users, that means their behaviors, and okay, and their usage or utilization about the product. What will be the economic benefits? Okay, what will be the economic benefits? That means what are the profit gains or losses, whatever concern or financial aspects with respect to that particular product. How would you characterize good output from the system? That means when you are saying something is good, better, best, then you have to have some kind of criteria or measurements, right? That when you can say it is good, when you can say it is better or best. So good output or good outcome or good resultant from the system, if you want to take it out as good, then what you have to do it, fine, and what is required. Now what problems does the solution address? So whatever solution you are designing or framing in before only or in earlier stage, is it going to solve the problems, okay, or whatever you can say different issues related with that product? What environment will the product be used in? That means same way, the way you are going to target the number of users or who are the users, area, crowd, same way you are going to do the survey for environment also, in which scenario, in which situation, in which environment that product or system is going to be used. Are you the right person to answer these questions? Means are you in that position, or do you have that much expertise? Otherwise these questions or these steps can be handled by some other expert person, okay, who can do justice with this requirement collection inception phase. Are these questions relevant, or some new questions or few more questions are needed to be asked here? Can anyone else provide additional information? Okay, if not that customer or end user, can you ask some more questions or new questions to some other person who will add some quality and value to your requirement inception? And should I be asking you anything else? That means whether I am left out with something, if I'm missing something, then you have to recall, okay, or you have to take help from others, that is anything pending to ask, right? So these are the important questions which are generalized questions needed to be asked to the end user or customer while your discussion is going on and when your dialogue is in between, right? That is inception phase. Okay, now going ahead, the next is getting requirements right. Okay, that means when you're talking about getting requirements right, that means how you are going to get the exact thing needed for the development or manufacturing. So few people have given their statements here, like to read any one of them, that we spend a lot of time, the majority of project effort, not implementing or testing, but trying to decide what to build. So there itself you need to give more time. If you're not giving more time there, that what to build and what can be the probable solution, then obviously you will come up with something bad or something with more errors and fault. So you have to give some time, okay, you can say you have to give some more time at the early or you can say initial stage only, where you have to decide or discuss about the problem statement and you have to visualize or imagine the probable solution. Right? Now the second step talks about elicitation requirements, right? So why is it so difficult to clearly understand what the customer wants, because there is some terms like scope, understanding and volatility. So what is the extent, what is the limit to what your system or product to be developed or manufactured. So scope will explain about the boundary of the system. Okay, the customers or users specify unnecessary technical detail that may confuse rather than clarify objectives. So scope need to be very much clarified here, because to whom you are going to develop your system, what is your targeted user or area or crowd or region, okay, to what kind of environment, in what kind of environment you are planning to launch your or release your product, whether it is online based, okay, that means something digital based, or it is something rest of application. So you have to think everything in detail. Understanding must be there for the following things, listed things like customers are not completely sure of what is needed. These are informal requirements. Customers have a poor understanding of the capabilities and limitations of the computing environment. They don't know technical things. They will just explain you or dictate you, or you can say describe you that what are their expectations. You have to convert those expectations or requirements into the technical terms. Then customers don't have a full understanding of their problem domain. Customers have trouble communicating needs to the system engineer, because system engineer will ask questions with respect to his expertise or her expertise, but so those kind of technical terms will not come from customer. They will explain in their own way. So we have to bridge that gap. Customers omit detail that is believed to be obvious. Okay, customers specify requirements that conflict with other requirements. Customers specify requirements that are ambiguous or untestable. So now it is a job of the developer or producer or the person who is from their side, that to ask different types of questions, so that even if some important information, okay, suppose that customer is missing to explain or describe, then in that particular question it can be taken out, the answer can be taken out. So these kind of understanding criteria are needed. And volatility means requirements change over time. So your system should be ready and flexible and feasible enough to accommodate such changes, okay, over time. Collaborative requirements gathering. Meetings are attended by all interested stakeholders. Okay. Then rules established for preparation and participation. Then agenda should be formal enough to cover all important points. Every meeting, every discussion must have some agenda, so that each and every point can be handled smoothly one after another, but informal enough to encourage the free flow of ideas. Yeah, it should not be the case that if agenda is set for any meeting, then no other points are discussed which are out of the agenda. So you have to keep some time or platform ready for all, so that they are very freely discussing about some issues which are not there in agenda. Okay, a few times it happens also that many things which you are discussing need not to be there in minutes of that meeting. Okay, but discussion should be there in front of all, so that collaborative decisions can be taken. Then a facilitator controls the meeting. There should be one facilitator or moderator who will control and direct the meeting and people. A definition mechanism like blackboard, flip charts, something is used. That means some aid is used where you are showcasing the presentation, you are discussing, some kind of board will be there for all the writing work and brainstorming session. During the meeting, problem is identified, elements of solution are proposed, everyone is going to propose their kind of solution, their opinion, their perspective, different approaches are negotiated, a preliminary set of solution requirements are obtained, atmosphere is collaborative and non-threatening, because everyone is talking, speaking and exchanging their thoughts and opinion with full freedom there. Okay, so it should be a coordinated and collaborative kind of meeting and environment. Quality function deployment. Function deployment determines the value of each function required of system. That means what kind of value or functionalities or services you are offering to your customer or end user. It should be of some quality. Information deployment identifies data, object and events. What information you are deploying or offering through those functionalities. Task examines the behavior of the system. Okay, and value determines the priority of requirements. Now elicitation work products. Now this is not that much mandatory to remember and to be written in answer, but just go through it. Elicitation work products can be statement of need and feasibility, then scope, then list of participants, okay, what kind of technical environment, list of requirements and constraints. Also constraints means limitations, list of usage scenarios, different scenarios and situations, and prototypes, if any prototypes needed to be used which are existing. Yes, hello students. Now we'll start with the next session, which will focus on the topic use cases. Now these use cases are the important scenarios which you need to use when you want to describe the different functionalities or services offered by your system. That means now we are entering into the design part, okay, or you can say modeling or analysis part. So I have told you we are going to use in this complete SCPM subject with the help of mini projects, we are going to use UML diagrams, that is Unified Modeling Language, and the version which we are going to use when we are drawing this UML diagram that is UML 2.0. Okay, so in UML 2.0 version we have total 13, that is 13 UML diagrams. So the very first diagram, whichever version you take, but the very first diagram which you always draw when we talk about UML diagram is use case diagram. So use cases or use case diagram will always focus on the functionalities of the system. Okay, so this use case diagram comes into both the aspects, static and dynamic view of UML diagrams. So it will explain what kind of functionalities, what kind of services, what kind of features your system or product is going to offer to the end user or customer. So a use case scenario is a story about how someone or something external to the software, which is known as an actor, interacts with the system. Now each and everything I am going to explain you with the help of diagram in my further slides and presentations. Right now just understand, when I am talking about use case scenario will talk or focus on situation. Okay, that means suppose giving the example, if I am going to an ATM system, right, and if I obviously want to withdraw, or you can say check the balance in my particular bank account, fine. So performing all these steps and then getting the slip at the end where everything is written and mentioned over it, which will give me the balance, okay, current balance in my that particular bank account, right. After that also I am withdrawing the money, again I am getting the slip which will give me some kind of reduction in the amount because I have withdrawn the money from the ATM, and then accordingly that slip will be generated. So everything is carried out very smoothly without any error, without any obstacle in between, without any fault, or okay, everything I'm getting very nicely till the slip is ejected out of the system, right. That means this is one of the scenario where everything is working very fine and in positive manner. But suppose that means always there are some worst case scenarios also. Okay, every time there won't be some success scenario, there will be few failure scenarios also. For example, suppose when you are going for your bank account statement or account balance checking, right, that time suppose you are entering your PIN number but some error or some kind of alert messages are coming with respect to your PIN number, that wrong PIN number entered or PIN number not identified. That can be one of the failure scenario because you can't proceed with the further things. Okay, if you are going for withdrawing the money, maybe the what you can say, again PIN number error can be there, or card insertion, that particular module or entity again can give some kind of error. So that is one of the scenario, failure scenario. Next scenario can be when your complete system is out of order, there is no money in that particular system. That can be one of the failure scenario because you can't operate it, no, right? No, not even a single step is carried out there. Fine. And at the end, you can say one more thing, that there is no receipt generation from the system. You can just take out the money, but there is no receipt generation. So earlier also you have not checked what is the balance, and at the end of the transaction also you have not get how much is left out. It means it will be only dependent on the message which you are getting in your mobile phone, or when you are going to update your passbook or your account details, maybe online or offline. So these are the other scenarios, but when you are talking about the ATM system, these can be a number of failure scenarios. So scenarios means different situations, either positive or negative. That means correct or fail. Each scenario answers the following questions like, who is the primary actor, secondary actor. Now this actor is a person who is going to initiate the dialogue or interaction with the system. So when you are going to draw this use case diagram, you will see one vertical rectangle which is called as the subject boundary or system boundary. Now the actors which we are drawing to the left hand side of that subject boundary or vertical rectangle, these left hand side actors are called as primary actors because these actors are going to initiate or start the interaction with the system. Whereas the actors which are going to draw on the right hand side of the subject or system boundary, those actors are called as secondary actor because they are going to get the outcome or resultant of the system. Okay, so you have to identify which are the primary actors, which are the secondary actors. Primary means, again I am telling that who are going to initiate or trigger the interaction or dialogue with the system, and secondary actors who are going to get the final outcome or resultant of the system. Next question. What preconditions should exist before the story begins. That means what are the actors' goals, what they want to perform in the system, what kind of prerequisites or preconditions should be there when your actual processing or system is going to work. So any prerequisites need to be ready, or any preconditions need to be satisfied before your system start working. What main tasks or functions are performed by the actor? What expectations might be considered as the story is described? What variations, actors, interaction are possible? System information, whether it is will be the actor acquire, produce or change? Will the actor have to inform the system about changes? What information does the actor desire from the system? And does the actor wish to be informed about unexpected changes? So all these are different questions. There can be many questions, but these are the generalized set of questions which need to be asked when use case scenarios are drawn. Okay. Elements of analysis model. So these are the four elements: scenario based elements, class based elements, behavioral elements and flow oriented elements. Now in these four kind of elements, all your diagrams, UML diagrams are divided. So when you're talking about scenario based elements, obviously use case diagrams will be there and activity diagrams or flowcharts will be there under functional view. Okay. When you're talking about class based element, class diagrams will be there, or object diagrams or package diagrams. Behavioral elements, state chart diagrams or state machine diagrams will be there, and flow oriented elements means data flow diagrams will be there. So each and every this section of elements and diagrams we are going to study in detail. So you can explain these steps as elements of analysis model through this one of the kind of diagram also. In other presentations we will see how to represent it. Now this is the simple example of use case diagram. As you can see, this thin persons here on left hand side of this boundary, you can see this vertical rectangle which is called a system or subject boundary. Okay, and this system or subject boundary is going to have n number of use cases. See these ellipses, n number of use cases inside their complete subject boundary or system boundary, right? Now when you're talking about this particular ellipses, these all ellipses, this means these are going to offer some services or functionalities of the system. So left hand side, these people like homeowner, system administrator, these are primary actors because they are going to start the dialogue or interaction with the system. See the arrows. You can also draw these arrows as unidirectional arrow. That means you are giving some point here like this. This is also possible if you want to show it is one-way communication. And if it is not one-way communication, don't draw any arrow. Just draw simple line. Okay, in the first case as it is. Okay, so this is your homeowner, system administrator are primary actors. So understand these actors, as the name suggests, are not only human beings or living things, they can be any systems also. So similarly you can see on the right hand side there is no actor kind of thing drawn. I can draw sensors. This is the entity. Okay, just an entity. So you can draw a system, you can draw an entity also as an actor here, but best way to use the symbol for an actor is this thing. Okay, then you can see different types of functionalities or services offered by the system like arms or disarm system, then accesses system via internet, response to alarm event, encounters an error condition, and reconfigures sensors and related to system features. So whatever happenings or whatever executions are done inside the subject or system boundary, the output will be given to sensors. That is secondary actor. So this is the generalized diagram for use case diagram. If you are going to go for detailing of use case diagram, you can always connect these internal use cases to one another. So you can use different kind of relationships here. For example, this straight line association can be used. You can use dependency. You can use generalization. Then there are types of uses also. Okay, types of use cases also. So everything we are going to study in detail when we are going to study the use case diagram. So when you are using dependency relationship between these use cases, then there are two types of dependency relationships in use case diagram. One is include and another one is extend. So all these things we are going to study in detail. Similarly, this is the activity diagram for requirement engineering, RE. So the activity diagram is of in this way, where you can see the ellipses of use case diagram are replaced by such kind of boxes. So these boxes, how they can be drawn? Two parallel lines with curved corners. Two parallel lines connected with curved corners, right? So these are the different activities or action states in an activity diagram. So obviously this circle, this one, then this one, that is a complete black circle, are the starting states. And these concentric circles, where the inside circle is a black circle, outside circle is just the boundary. So these three circles are end states or final states. And the above three circles are initiating states or start states. So in between these two circles, starting and ending state, or start state and final state, all these boxes which you are seeing, these are actions or activities. Okay, so these are the actions boxes for this complete activity, and this diamond is a decision box, so either yes or no. Then this complete, you can see horizontal dark line draw here, that is called a synchronization bar. Okay, so this synchronization bar, when they are giving this kind of two arrows, that means they are acting as a fork there, because their input is one and outputs are many, more than one, so it is acting as fork. Okay, but when these two arrows, you can see here, they are joined here, one more synchronization bar is here, right? So these two arrows are joined here, and you will get one output which will go to final state. That means two inputs and one output. Such kind of thing is called a join. So there are n number of things which you need to study in activity diagram, but these are the important terms. Okay, then moving ahead for class diagram, that means this particular is a class representation where the topmost is sensor class name. Okay, then these name, ID, type, location, area, characteristics are all attributes of that sensor class, and identify, enable, disable, reconfigure with round brackets, all these are methods or procedures or functions of that sensor class. So in this way we can draw a class box where three partitions or three sections can be there. So similarly in detail we can draw n number of classes connected to each other. Okay, that can be a complete class diagram. That earlier said only focuses on a single class. Same way, this is a state chart diagram where a state box is explained here. Again three sections, and these are the two parallel lines connected with curved, you can say curved corners, right? Arcs. So this is the representation for state box. So first section, obviously reading commands, is state name. Second section is state variables, that is system status is ready, then display message, enter command, display status ready. Okay, so whatever message or text you want to enter, that will be written in quotes, double quotes. And third section is about state activities. So it is similar to class only, where activities can be entry, ready, do. So all these are different activities. Entry, exit, all these are activities. So this is a single state box. Similarly, you can draw multiple states and connect to them so that it will become a complete state machine diagram. Okay, so this was about your second section of your unit 2, that is requirement analysis, where few UML diagrams notations are explained. So further parts will be explained in the next session or next video, where we are going to study detailing of the further UML diagrams. Okay, so let's close the session here. Thank you.